the microphone is not picking much up. Anyway, Layla will tell you that your time is up, so... yeah, it's barely audible, but what are you going to do?
Okay, and I think to get things started, we're going to start with mailing list analysis. Is that? Yeah, Niels? Great. What's it? You can just upload directly. Has anyone sent me their GitHub ID yet? You can upload directly into the project, and then that way I don't need to do anything for you. All right. Okay.
Can you do the full screenification?
Okay.
Timer, ready, set, go. We've been working on a tool for qualitative mailing list analysis on IETF mailing lists. What it does now is doing data collection on the 34 gigabytes of IETF mailing lists. It does basic statistics, word analysis, and network analysis by using Jupyter notebooks and Python. We came up with quite some interesting issues that happen when people run their own mail servers with weird encoding issues, weird dates like 32nd of January, and Unix time. It's beautiful. You can find and contribute on GitHub in the Big Bang repo. And we've been working on this with a lot of academics and civil society people. So we've been analyzing roughly 2 million emails from almost 200,000 email addresses from 955 mailing lists. There are a bit over 1,000, but these were the ones we could grab and that were not too weird. One email address sent about 80,000 of those emails, but most contributors sent 1 or 2 messages which could indicate a spam issue. What is interesting is what you see here is these are, most of them are mailing lists, but also some individual contributors, is that you see that the community is quite modularized, but also quite integrated, which is probably, yeah, to be expected and some good news. There are some outliers, we won't tell you who they are. So another question we had of a presumption is that mailing lists are often dominated by early participants. That's not true. So we've been researching into tenure. It's a complicated analysis. Nick will tell you everything about it if you approach him after the session. We've also been analyzing the number of messages sent by contributor. And even though a few people send a lot of messages, there is a pretty good there's a pretty long tail, and a few people are not dominating all the lists here as well. So what's interesting when we look at individual email lists, such as IETF at IETF.org, if you look at the longest threads, these are all quite recent. So this indicates there is still quite some active discussion, and some of you might be interested in the discussions that actually brought up so much stuff. Then we could also come up with centrality, and you can see the redder they are, the more people reply to people, and there are also some famous people that speak a lot but do not reply to anyone. we can also do word trends, and there we can, for instance, see that there is a steady increase in the mention of privacy, security, got much more uptake, and access got popular and then less popular over time. You can do with it whatever you want. So, if you want to do funky analysis and come to cool conclusions, join us and make pull requests. See you later.
Okay, great, thank you. So, in case you're wondering the order, I'm going to kind of go in. First in is first to present. So, Doe, did you guys have a? Yeah, you do have a presentation. Oh, you don't want this one? Whoops. This no.
That one.
Oh, you're
Yeah, way down.
This no. Here, you pick it. All the way at the bottom. Oh, okay.
Okay, so this is your 4 for the price of 1 bumper DNS presentation. I'm going to cover louder. Can you hear that? Okay, sorry. So I'm going to cover DNS service discovery, deprive, and DoH, all in 3 minutes. When we turned up yesterday morning, about half of the people here were interested in working on DNS over HTTP, which is DoH. So they looked at multiple implementations of the 03 version of the draft, and the other half of the folks here wanted to work on smaller projects in the other areas. So what got done in DoH? If you're interested in the nitty-gritty details, follow the link at the top, which will take you to a repo which tells you everything about these implementations. In overview, we had 7 different implementations in everything from C to JavaScript, and we also had an interop test framework that got started as well. What was learnt? There will be a full report at the DoH working group, so if you're interested, go along there. But the main thing that we learned is, wow, don't you learn a lot when you put DNS folks and HTTPS people at the same tables and they write code together. The headline is, it mostly works. Most of the interop was okay, and there's also interop with the public servers that are available for this. There were 2 very specific feedbacks for the draft. One was that the draft didn't say enough about should and musts on implementing get and post, so that's going straight back to the authors. And also that, oops, error handling was completely unspecified in the draft, so that's going to go in there. As you'd expect, we worked through a whole bunch of minor clarifications and bugs. We had one fail where DoH was not a good fit for the Go DNS library, where DNS over TLS had already been implemented. And also, who knew? You can write a Perl DoH client in 20 lines of code if that's how you get your kicks. In the other areas, for DNS SD, Ted and Stuart spent the whole weekend working on the MDNS relay implementation. There was work done on an old draft that optimized how you do IXFRs for DNS sec sign zoned. And what they wanted to do was some measurements to see if it was worth resurrecting that draft. They didn't quite get there, but they made good progress. There was an epic fail in trying to implement Edward Curve's validation, but we thank Nick Harper for help with ASM1 in that respect. Some issues were thrown up in trying to implement the latest KSK Sentinel draft, and there's also work on A-name. And to wind up, we also did some work in deprive. So the Get DNS library and Stubby can now connect to resolvers just by name. And this works for a URI for a DoH server or a name for a TLS server. We also did a bunch of implementation work around TLS in systemd resolved and bind, DNSPer for benchmarking tool. There was more work on padding, and also an experimental chain server is available. And just to put up the names of the teams that I haven't mentioned so far, we had 2 remote participants and 5 first-timers. Thank you very much.
Okay, thank you. Nice use of the template, too. Okay. So, how about I2NSF? Oops.
Okay, thank you, Charles. Hello, everyone. This is Jae-Paul Jung from Sungkyunkwan University in South Korea. This time, my student, PhD student, Jin-Young Tim Kim, and I championed I2NSF project. So I2NSF is for the how to apply netcomp YANG and less-than-comp YANG to enforce high-level security policy into network security function level security policy. So this time, 7 grad students at Sungkyunkwan University, 6 students are participating in this hackathon. My PhD student and I participated in this hackathon. And our source code located at this GitHub link. You can access it. So this is a poster and shows the brief. So 3 professors and other research institute, Dr. Park and also Korea Telecom, Mr. An participated, and also student list. So in this hackathon project, we show the 2 things. The first one is the dynamic configuration, which means map security function to actual network security function located at a security controller. The second one is a consumer-facing interface based on REST-conf and the latest YANG data model. So let me explain one by one at a time. So you can see I2 NSF user is administrator of program. So it has some policy such as during our work time, employee cannot access some other websites such as Google, YouTube, and Facebook. So that kind of security policy delivered to security controller using this kind of YANG data model. So we can import that policy. So security controller using dynamic configuration requested security service is mapped into actual network security functions such as firewall and the web filter translated. And then that policy translated by this security controller and actual firewall, web filter, network security function are mapped. So that kind of security function automatically are mapped. So we used this kind of open source. And also we demonstrated our hackathon using this network configuration based on a mininet, okay? So web access blocking according to user group. So this is the project GitHub. This time we showed our database netconf model works. Thank you for your attention. Okay.
Great. Yep. Yeah, we need a louder speaker for your music. Okay. So the next one, what's going on here? Okay, so how about, we don't need DO anymore. So the dots.
Thank you. Hello everyone, let me introduce the achievement of DOTS interop. So our hackathon plan is here. We tested the interoperability between independent implementations in order to see the maturity of these core specification of DOTS protocol. Now we have 4 implementations. One is OSS by entity, so it is open to the public, and rest 3 are from different vendors, NCC Group, Arbor, and Huawei. So this spreadsheet shows our achievement. We checked we enumerated the important features of the spec, and we checked if it is supported, and also we checked the interoperability of those features. Basically, the test was successful because we could make it more green during this hackathon. So here is our status. So DOTS, again, DDoS, Open Threat Signaling Protocol, protects the internet from DDoS attacks. It makes DDoS protection more effective with its programmatic capability. So now we confirm that we can do cooperative DDoS protection operation between at least 2 individual implementations. So this screen capture is most impressive one for us. We successfully did a mitigation request from one OSS client to proprietary server from NCC Group. Actually, the server is a DDoS mitigation appliance. And also we did the same things, vice versa. So here is what we learned. I can dare say we can meet the expectations for a DOTS protocol from the market soon, because the core most important specification is almost stable. Then in this hackathon, we tested based on the latest specification, so it is proven to work. Then also we discussed a lot about the current draft. Also we talked about the new features, and they will be shared to the working groups. And also we will talk on on Tuesday working group. Yeah, here's a wrap up. I'm more than happy if we could include more people in the next hackathon. Thank you.
Okay, so how about this one? EMU, hackathon.pdf. Don't know which group that is. Oh, EAP TLS.
Hi. So we were the EAP TLS team, and I have just one slide on what is EAP for the benefit of those of you who don't know EAP. EAP stands for Extensible Authentication Protocol. It's used typically for network access authentication. Here is one example deployment where you would use EAP, or you might use EAP, is if you're trying to connect to access point, then you first authenticate yourself with EAP, and then you can actually connect to it and get internet access. So EAP runs end-to-end between your laptop and the server. There's a bunch of EAP methods. It's not new. So over the past 10 years, we have EAP TLS, we have EAP AKA, which uses SIM credentials, we have EAP password, a lot of them, but we were just looking at EAP TLS, which is quite widely used, especially in enterprise wireless access authentication. So some of you might know that EAP method update group was rechartered and restarted. It was actually just rechartered last month. And during the recharter discussions, there was people reporting on the mailing list that there are some deployment issues with EAP TLS. And they noticed that certificates have been growing larger, especially with RSA keys of 4096 bits. And the chains are also getting long. And this is the case in many enterprise deployments. And what happens is that even though both the client and server have valid certificates to authenticate each other, they fail because access point implementations drop EAP sessions that don't complete within 40 packets. So our goal was, can we reproduce this error? So in that terms, we were probably the only team that was trying to break something that already works. So we started in the morning yesterday by trying different types of configurations. So we had like many intermediate CAs, and to reproduce the error, we tried to have very long chains and large certificates, so we were only using RSA keys, but we were still unable to produce the error. So it was still authentication successful, and we were very disappointed. So what we did next is there is a configuration parameter that allows you to reduce the maximum EAP packet size. The default was 1396 bytes, and we reduced it to 200 bytes, and voila, we have a failure. So the AP barfs, as was reported on the mailing list. But we also noticed that for this to actually happen with the default 1396 bytes fragment size, you would need to have chain that is roughly 55,000 bytes. So that's, yeah, we sent this input on the mailing list, and we'll probably discuss this tomorrow when EMU meets. We are also continuing our tests with ECC-based certificates to see how things are. We had two first-timers, Alexi and Claire. And then Darshak and I have been before to the hackathon.
Good job. Okay, and thank you to people for honoring that 3-minute time limit legato.
Hello, everyone. I am going to present about that Young-based EVC service modeling in OpenDaylight. This is that overall architecture over there. So Legato is interacting with that business application, or it could be in the Postman, which is, or be any REST client which is interacting with that Legato. And rest of the thing is underlined. For example, Legato is interacting with Presto, and Presto is communicating with that underlying infrastructure to create a flow or create a link between those switches. So here we use Mininet, hence we don't get time to use that actual network box devices. So we used Mininet, and in the Mininet we created the flows which have the two switches, and between the switch 1 and switch 2, we're just creating that EVC. This is that Legato module. It's a Young-based module, and it's flexible. We can install it and uninstall it at any time. And if we install it, we can see those list of APIs for that Legato is visible in that API doc explorer. And you can see that all those card operation for that Legato, we can delete, get, update, post, all kind of operations we can do from that, either from that Explorer screen, or we can do from that Postman script. And this is that implementation over there. So there is two offices located. One is San Diego, another is that Los Angeles. And those two have that two UNIs are defined. And inside the service provider network, we're creating point-to-point EVC over between UNI and UNI2. And it's also possible to create multi-point or EVC tree. But right now, we are just creating that point-to-point EVC. So we are establishing relation between link between that UNI1 and UNI2. And I'm sitting over here. If you want to see any demo, just let me know. Come to my spot. I'll show that what the steps we did, and I can run that small demo for that creating of EVC between two UNIs. After that UNI, we can verify the flow, that data is going from one endpoint to another endpoint. And after that, the deletion of that EVC, that flow traffic will drop down. And then again, we can verify that, is it working or not. OK, that's it from my side.
Okay. Next up, multilingual email.
Great, thank you. Okay, so the original plan was to try to get some email implementations of this new multilingual email type underway. The RFC that it is referring to is the RFC 8255, which is a new one that was finished off at the end of last year. The idea is you can send multiple translations in the same email, and the client will identify which is the correct one to show to the recipient based on their preferred language. So the plan for me was to bring along my Java implementation that was almost finished and use that as inspiration for other people with implementations of their own in their own languages. What we actually achieved, well, the plan changed slightly, and we developed an email reflecting service that sits on an MTA, and it transforms a regular incoming email and returns an email to the sender, which is of exactly the right kind of format for multilingual email, according to the new spec. We also developed some client code that sits inside Neomut, or will do when they merge it in, and that correctly selects the email part, given a new preferred language configuration that you can set in the client, and that will select the right type, the right part of the email given that configuration. And also, we had a little bit of feedback into my Java implementation that was very useful. So this was the original plan that we circulated between us before the event. There's obviously quite a lot on there. So we selected two things. So the top one is the code in the client side for NeoMut, so that when you receive an email, it shows the right part given those preferences. And the one at the bottom is the reflector code, so that you can create those correctly formed emails. So I was going to skip over this one. So to use a reflector, it's just send an email, plain text email, with a specially formatted recipient address, and then that code looks at that address and then sends you back an email, multilingual email, with all the parts and the translations obtained from Google Translate. So for example, this has got English, French and Spanish, and it gets those from Google Translate, creates the multilingual email and returns that to you. As for the NeoMut client side, part selection stuff, so on the left is what it would look like before any kind of implementation was added. At the top in the middle is the preferred, when you've got your preferred language set to French, that's what comes through. And then, right, okay.
Sorry about that.
And that's all the code is completing up on GitHub.
So just a reminder to everyone, I really want to encourage you too. I know 3 minutes is not nearly enough time to do justice. Please do consider joining us tomorrow. Yeah, Monday, 6 to 8. We'll have the happy hour thing where you can come and talk, in depth about your presentation. So, network time security. Do we have? Okay, great.
Yes, hello. On our project, we work on the network time security protocol, NTS. It's a protocol, security protocol to protect time protocols like NTP. And our our goal yesterday was to find remaining issues in the current NTS draft. So the question is, what is the best way to do this? We have currently 2 different implementations to complete independent implementations. Both are still in progress and have a proof of concept character. And we performed yesterday the first interoperability test to find out if it works or not. Our test scenario is pretty simple. We have a small NTS client and NTS server, 2 devices with 2 different implementations. And the test results were very interesting. We have 2 parts in the communication. The first part works over TLS 1.2. Here we have a NTS key exchange. It works perfectly. We have small issues, but we solved it. No, it works. But the second way, the time exchange over NTP failed at the first test because we have a misinterpretation of the NTS draft on the server side. So this was a little bit tricky yesterday, but we fixed it and we improved the NTS draft. So in the second one, it works correctly, and we can avoid such problems in the NTS draft in the future. Okay. What we learned, the interoperability test is pretty important to find hidden issues within the specifications. Now we know as our NTS draft works is correct, as our implementations works correctly. And we have some small issues. We have to discuss some small problems, but it's not a big thing. And yes, we have to finish other tests. We have tests only client and server our implementations, but we have to test the other way. Okay, so it was. For more information, you can join us on GitHub or yes. Okay.
Thanks. Okay. Up next, Lark.
Hello, my name is Sanjay Mishra, and I'm just going to be walking through as to what we did in this weekend. All right. So the area that we actually worked on is having to do with delegation of HTTPS video session. And in particular, at the hackathon, we worked on a CDNI use case of delegation, basically, of content from an upstream CDN to a downstream CDN. And specifically, a use case of upstream CDN delegating HTTPS content to the downstream CDN. The key goal, of course, for us is interoperability testing was to ensure trust boundaries are maintained to the right, as you see here in the picture, and also the end user privacy is not breached. A couple of other things to call out here is that in the delegation model, the trust boundaries are maintained, and then the redirection as it happens, whether it's DNS or it's just simple HTTP redirect, that can occur. Also that the ISP caches only hold the certificate without the private key of the content provider, in this case, video.example.com. And all the decryption material and everything in the keys are held by the Lark server, which basically returns the decrypted master secret, but not the private keys. So the use case really is that we have an end user requesting to watch a content from example.video.com, and the content is hosted on a CDN of choice by the content provider, and then delegated by it for the downstream to the downstream CDN, which in this case is the ISP cache on the edge of the network. The flow really is that the user would request content, and then through the DNS CNAME delegation in this case, CDN would the content provider would redirect to CDN, and the CDN would redirect it to the ISP. For the TLS handshake over Lark, here's what we have done. Basically, the two key aspect is that the TLS handshake occurs with the Lark client, which we did on the Nginx server, and between the Nginx, which is the Lark client, and the Lark server, that happens over the Lark protocol. So just to quickly wrap up as to what we did here was, for the interoperability standpoint, we used a client browser, and for the trial over the last 2 days, we really just used Chrome and IE. The Edge server software was basically an Nginx we used to patch the OpenSSL, and then the end server was, I guess, time's up.
Okay. My apologies for being so brutal on the time, but I think we have to be. Okay, mailing list analysis we already did. So, Yari, are you here yet? No, we'll come back to Yari later. Riot DHCPv6.
Hello, I'm Martin Lenders, and basically I wrote a DHCP client for Riot all on my own this weekend. So the goal was to provide a minimal implementation for prefix delegation, on the basis of the current draft for an update for the DHCPv6 RC. And the motivation was that we currently have a very quick hack version of something that resembles DHCP but isn't really DHCP, which is called UHCP, to configure the prefix of a 6-low border router so that it can disseminate its information throughout the WPAN. And so for our implementation, we required the message behavior for client for solicits, advertisers, requests, replies, and renews. We had a very simple setup so we just had a Riot native instance, which means that we can basically run Riot as a process on Linux and a Kia DHCP server to run our tests against. And yeah, we did manage to implement the behavior for solicits, advertisements, and requests, but we didn't. I didn't manage to implement the parsing of the reply messages yet, so no configuration happens actually right now. But as you can see in this little Wireshark dump, there are actually the messages exchanged between the server and the Riot instance. So what did we learn from the weekend? Well, the most important lesson, I think, is don't get lost in details. It took me maybe half a day to get all the information out of the DHCP specifications and put them in a header, which I guess if I would have done it a little bit quicker and a little bit dirtier, I would have been a lot faster with that. And when in doubt, ask the author of the draft or one of the authors, and I have to give thanks to Tomic for helping me a lot out at this weekend. And further steps is, of course, to clean up the implementation so it's a little bit more camera ready, finish the implementation of prefix delegation, then maybe later on down the road provide more support for other DHCP features. And I already PR'd the pull requests to the Riot repository, so if you want to have a look at the code, it's about 1,000 lines of code. You can do it under this URL. Thank you.
Okay. So, TLS, I'm going to come back to TLS because that's going to be a remote presentation, and I'm afraid of how that's going to go. So, here you go.
Hi everybody, I'm Lucas Pardue. I work for BBC R&D, and I was running a little umbrella project, so to speak, called Making Multicast IP More Successful. So if we think about what our problem was for the table to solve, is that mass audiences for IP-based TV distribution causes scalability issues for the internet. So do some mathematics, 20 megabits per second per stream times 20 million streams is unhappy for various people around the world. So one means to a solution for that is multicast IP, or IP multicast, and we think that's a scalable way to address audiences, but it's been used to date, but success has been limited across unmanaged and heterogeneous networks. So we'd like to reach audiences across disparate kinds of networks. We realize that inter-domain multicast is difficult and not universally deployed, and we have this idea of multicast islands. So we want to improve discoverability of multicast beyond, say, maybe traditional means like SDP. And I'll come on to that in a little bit. One solution to some of these problems is automatic multicast tunneling. And that helps you reach clients that maybe don't support native multicast reception. But moving over to the streaming formats, say, we think that HTTP-based streaming is the future. It's pretty good for unicast, and file delivery enabled new kinds of content experiences. So what we wanted was a solution to deliver this over IP multicast. So we looked at something like QUIC and thought that this was UDP-based HTTP. Could we make it work over IP multicast? We wrote up a draft that kind of does this in a server push context, and at BBC R&D we built an end-to-end prototype using Google QUIC, and we've had a demo on our table this week showing that on a Raspberry Pi. Our ambition was to move to IETF HTTP over QUIC. So to enable us to do that, we took our current demo, we wanted to deliver it into this building. We had some of my colleagues working on the implementation, a new client library, or client and server library to do HTTP over QUIC, built on top of NG-TCP2. We're also looking at different kinds of clients. So could we have a browser-based version of this and try and address some of the multicast into a browser considerations for these things, and test bedding. And I mentioned AMT earlier. We had Jake Holland joining us, continuing his work at, well, on AMT at the hackathon. I've got an architecture diagram. I won't go into this in too much detail, but you know, multicast delivery is hard. So to get multicast from our home base about 15 minutes away from here, we had to go over a GRE tunnel and have support from the IETF network team. That was great. We got that delivered to our table, and we had various kinds of clients consuming that stream successfully. And what we got done was we continued the work. We did that end-to-end test successfully. We made some progress. We did design early implementation on this stuff, and we learned loads of things. Thanks. Bye.
Thank you very much. Okay. How about NEAT?
Hey, hello everyone. So to give you a little bit of context, the problem we are trying to solve here is that on the internet today, when you want to retrieve some unicorn picture, you just have too many ways of doing it. You can do it through your phone, through your Wi-Fi, through your wired link, and sometimes your wired link is multi-ohmed. You can even go through a VPN, etc., etc. You have many ways of doing it. So that's why the MIF working group defined the notion of a PVD, which is the consistent set of information that you get from all your different uplinks that lets you connect to the internet. So now what we are trying to do in the inter-area working group is to add some more information attached to those PVDs by retrieving a JSON object from the different upstreams. So each upstream is going to give you some more details about the characteristic of each link, such that when the application wants to retrieve the picture of the unicorn, it can decide between, you know, which wanted to use an expensive, the captive portal upstream, the fast upstream, or the secure through the VPN. And in order to present that information to the application, we use the NEAT project, which gives a middleware such that application can as well retrieve this information from the upstream, the uplink characteristics. Now, one aspect is that if one of your uplink happens to be a captive portal, well, we have something that's pretty nice, is that you get your PVD as usual, you retrieve your JSON object, and that JSON object is actually going to tell you that you're captive, such that your laptop can connect to the captive portal API and possibly dynamically authenticate yourself such that you get access to the internet. So that's a way using the PVDs to dynamically attach to a captive portal uplink. Finally, one aspect is that in IPv6, when you have you have a multi-home network, you don't want to do NATs. So there is some work going on at IETF, and it's using source-dest routing, which basically means that you're not only going to look at the source, the destination address, but also the source address to route the packets. So during this hackathon, we made a complete test topology with all those components plugged together. The PVD object, we had 3 different PVDs. One of them was captive. We had some Linux routers, some Cisco routers doing SADR, array DVD, some Linux kernel was patched, the PVDD, glibc was patched. We also have an implementation in OpenDaylight. So no, not all that was done during the hackathon, but we plugged them all together and had some fixes done to make it all work, as well with the NEAT project. And now we have a Wireshark dissector, and you can find all that on the GitHub. We also had some work with the captive portal done by Kyle. Thank you very much. Just 5 seconds. You can fetch the code and the draft. Thank you.
Well done. Okay, great. And let's see. We still have a few left, but if some of you haven't uploaded your presentation yet, please be sure to do that. We can make another round and get back to you. So, Spinbit, although I know you have a better, longer name.
Okay, good afternoon. So we've been working on scalable privacy-preserving in-network bandwidth-independent technology, or Spinbit measurement in the QUIC protocol. So first question is why? What the Spinbit gives you, it's a explicit signal that you can use for passive per-flow RTT measurement. So we need this because QUIC does not expose transport internals on the wire, which generally is good, but it also means that if you want to do passive performance measurement, the quality of your data is much worse. So the Spinbit can be used to replace this loss of visibility, and it effectively gives you something similar back that you would get in TCP from looking at sequence number and acknowledgement sequences or timestamp sequences. It's also superior than if you would just do a handshake measurement because you get samples all through the flow, and you don't measure any overhead that's related to setting up the connection. So how does this work? Well, when a client initiates the connection, it starts sending packets to the server with spin 0. Then the server will always reply to the client with packets that have the same spin as they last saw from the server. And then the client will always do the opposite, so it will always flip the bit and then send it back to the server. So that way you get this bit that spins through the network. And if you then have an observer on the network and you just look at what these bits are, you extract the waveform, and then you just measure what the half period is of this waveform, then you get the RTT of your network. So what we've did is we've implemented this into a couple of QUIC endpoints. So that's Mink, PicoQuick, Quickly, and QuickGo. And what was really nice is that we saw for each of these ones, basically what you have to do is you have to spend some time familiarizing yourself with the code base, and then you need like 10 minutes and 10 lines of code to add the Spinbit. So it's really super simple to implement. And then we also looked at a bunch of implementations for observers for this. So we have one that's really minimal, just built around Go packet. We have one that's used around VPP, which is sort of or around an experimental measurement platform that we have that is based on VPP. And then we also have a P4 parser. Yeah. And then a whole bunch of other projects, but the results of those we will hopefully be able to present at Hackathon 102. Thank you.
Okay, thank you much for that. Okay, Suit. Great, I see Hannes running up.
Okay, we worked on firmware updates for IoT devices. And this is a recently formed working group and deals with the basic problem that you start off with an IoT device, comes out of the factory, and later you figure out that you have to update that device because there's some new bugs that have been found, there's some new features that you want to add. And so that's what this group does in describing the manifest metadata to the firmware and providing that firmware update to the device. So we wanted to provide feedback to the working group. And by looking at the manifest format, which is a digitally signed CBOR COSI construct, we wanted to get as the figure shows, we wanted to get the firmware image with the manifest to the device, in our case using UART, but we've also had Alex to work on a LoRa-based delivery. And we used this one specific board called K64F NXP board. And there's a bootloader on that device that reads that stuff, verifies the digital signature, and installs the new firmware. We had a couple of people participating. Most importantly, two new participants from Marcus from Infineon and Max from Texas Instruments, and my coworker Brandon from Remote, who will be here next week. So it's a first-time attendee. It was a pretty ambitious setup. So we initially started off with the setups of the development environment, online IDE, desktop IDE, command line environments. We got the code working for manifest creation, which is in Python. Max worked on a pseudo bootloader on the IoT device and also on the update mechanism using UART. The LoRa one is still work in progress. We got all the setup with the keys and the examples. The C code for the verification is still work in progress. We're still dealing with some issues, which I will describe on the next slide. We produced a write-up, which you can find on this Etherpad link if you're interested in the details and want to reproduce this. We ran into some challenges. First of all, for those for the guys who haven't been involved in this work, setting up the environment and the Python and all the embedded development environment wasn't that easy. We also had to update the firmware on the device. There's a separate bootloader there for UART communication, and also debugging, of course, is more complicated. But most of the time we spent on tackling issues with the CoCC library. That's it. Thank you.
All right. Perfect timing. Okay, and next up, DNS. We already did that one. Okay. Did we do the DTN? Okay. DTN, though, we didn't do this one yet, did we? No, I don't believe so. Do we have the presenter coming up? Okay, I see you now.
Hello and welcome to our presentation. We are DTN, which stands for Delay Torrent Networking Team, which is basically Internet in space. That's what we are trying to address here. We are from Xworks, and we also have micro-PCN participants, which is the referential implementation of the protocols I will talk about on the next slide. So, what was our plan? Our plan was actually to check whether referential implementation micro-PCN meets following drafts. There is bundle protocol version 7, which is going to turn into standard pretty soon. We hope it's going to be proposed actually this Friday. And then there is DTN TCP convergence layer protocol, which is RFC 7242. We focused on two problems to be solved. The first one was whether there is enough information in the draft to do the bundle encoding and decoding. That's quite complicated in this protocol because we are trying to save as much space as we can. So there is CBOR and all kinds of optimizations regarding size of the bundle. We also wanted to create an easy-to-use API because micro-PCN provides a lot of functionality, but it's not very intuitive to access that. So we created a REST-based API, and that can be accessed via Postman. And we also had difficulties to reproduce test cases, so we virtualized into Docker containers all the work we did. So how we did it? We created another implementation based on specs, and we let it talk to the referential one to find out whether or not there are some difficulties or whether it works. So, okay, results. We had some interesting discussions with telco operators. As said, bundle protocol was originally designed for space communication, but they pointed out there might be useful use cases also on Earth, which was kind of surprising for us. We were discussing providing delay-tolerant peer-to-peer data network in developing countries. So basically the idea would be that you have ad hoc Wi-Fi or Bluetooth or something, and you would distribute information hop by hop. The trick is that the other party, the recipient of your information doesn't have to be online. So there's a kind of like opportunistic connectivity. We have a new code which you are welcome to access. It's called PyDTN. During the interoperational testing, we found an issue that microPCN actually uses special header which does not meet the draft, and surprisingly, it was for historical reasons. Yeah, okay, we are running out of time. So feel free to actually see us tomorrow to answer your questions. This is our team. Thank you.
Thank you. Okay, so we'll see you at the happy hour then, and I hope many others. There is a sign-up page, if I can get my mouse back. It's on the wiki. If you're having problems finding it, I'll share a pointer with it later. All right. So, who am I missing? Okay. Thank you. Okay. $451. All right. Great.
Thanks, Charles. So we've been working to validate HTTP 451, which is a legally withheld HTTP status code. This is RFC 7725. Our work is part of the Human Rights HRPC group and Public Interest Technology group. This time we've had new contributors from around the world, some from Mauritius. We've also got a bigger group working on this technology. We've got 3 new code modules, which makes now 7. We're trying to answer a question: can protocols increase transparency and serve to protect human rights? So it's a slightly social question, and we're using code to answer that. So I'm going to hand it over to Hirotaka, who will talk about the new code and the new implementation.
Thank you. So we had 3 modules we have implemented in this hackathon. So to evaluate to measure how much website actually using the 451 status code, we made a crawler to crawl the web page. Actually, we are crawling the Reddit website right now. And also, if we found the 451, we need to have some corrector, so we implemented the corrector. And also, to visualize the results, we made a dashboard of that. Thank you. So this is a dashboard. So actually, we haven't found any 451 status code on the production website, but if we find some, we can the crawler will send to the results to the collector, so we can see that what's happening on the those websites. Thank you. So we have worked on from the IETF 99 Prague, and we have that Singapore at the crawler, and now we have the collector to correct the results from those browser extensions, plugin, and also crawler. Thank you. So that is our plans. So as soon as we correct the results, we hope we can fix the implementation, or we can improve the RFC. And that is our team. Thanks so much. And you can get the code from the github.com. So please take a look at this code. Thanks so much.
Okay. So the LPWAN project, I see coming up. Great.
Good afternoon. Okay, so this work is done within the context of the LPWAN working group. The purpose of the LPWAN working group is to compress IPv6, UDP, and co-op over low power wide area network technologies such as LoRaWAN, Sigfox, 15.4G, and NB-IoT to start with. And so we have one draft which has been in working group last call for some time now that we are trying to complete. And so the purpose for this hackathon was to consolidate the the pieces of code that we have for the compression part and the fragmentation part of this draft. Also, one piece of code has been developed on a computer using full Python, not MicroPython. Some other parts have been developed for these little nodes that run MicroPython. And so the purpose was to get all that together and see it running. So what we achieved? Well, we achieved dissemination of the knowledge of those boards. Team members got to play with those and understand and master them. We discussed the QUIC principles with some of the people, newcomers and other team members around the room. We ran the existing pieces of code. Everybody got to experiment with the existing pieces, and then we started the real stuff. First implementing on the server side, replacing JavaScript code with Python, fixing bugs that we found in the compression implementation, also sending fragments over LPWAN using a new board brought by the Riot team. So not quite integrating the fragmentation on Riot, but bridging between the two. And actually this was used at the suit table to do the firmware update over LPWAN. So we would send the fragments of the firmware. And yeah, I think we also got focus time to work on our implementations, to discuss and have fun reuniting as a team. What we learned, yes, once again, it was said before and in previous hackathon as well, it takes time to set up the LoRaWAN gateways, the LPWAN gateways in general, the modes. Debugging takes longer. But we got that working yesterday. And then we fixed typos, discussed the interpretation of the draft, discussed the implementation of this draft. So I think we are in better shape now than yesterday. And more coding to be done. Here are the references.
Okay, great, thank you. All right, and Yari, we'll have you up next. I just need to find your presentation. Here we go.
Thanks. So my name is Jari Akko. I work with Artyom, Tero, and Brian on various kinds of measurements tools or little tests that we thought were interesting for some reason or the other. And there were actually a couple of different things. So the first thing that we worked on, and I've been working on a little bit for the last couple of weeks, is basically experimenting with different algorithms that would do a similar thing as traceroute does, that sort of figure out what hops there are to a destination or how many hops there are. And it actually turns out that it's quite an interesting space. I've been trying to figure out if there are different algorithms that would actually excel over other algorithms. So here on the picture, for instance, you see the traceroute algorithm basically just increase the TTL or decrease it until you hit the right destination, and that's sort of grows linearly as your destination is further away, the more packets you'll need to send. And then we came up with this idea of a binary search. You can sort of try and guess where the destination might be, and then depending on the answer, you'll go either on the lower or the higher half, and that actually obviously scales better. Now, whether that actually matters depends on whether you care about sending many packets on the network or not. If you're just debugging your own network, it may not matter. In some other cases, it might actually matter. And sort of the random looking graph here is a comparison algorithm, just doing a random test on the different kinds of TTL values and then deciding based on that. And that obviously gives random results. The other thing that we were testing on was or making this little tool that would figure out if a destination supports which TLS version. And it can be used for many ways, for instance, testing across the internet for popular sites, what they support. So for instance, this afternoon I did this test where included I think 60 most popular websites on the internet, and came up with the answer that the average TLS version across the internet for those sites is 1.2032. And there's a couple other things as well. So we're not really sure where this leads, but it's at least I found it interesting hacking, which I like to do. So that's it.
Okay. So we have a TLS 1.3 presentation. Logan, can we hear you, or do I need to do something so we can hear you?
I think you should be hearing me right now.
Yeah, we can. We get some feedback, but you're audible.
Okay, so now, is it better?
The audio's not great.
Okay, how about now?
Is there anyone from Miteco or any of the audio folks? Are you here? I'm not sure what to do to make that a little better. Oh, hold on just a sec. We're going to see if we can get your audio a little better, Logan. Anyone else with a presentation we haven't done yet? We got them all? Anyone want to do a presentation, like anyone want to talk about your project where you don't have a presentation, you're welcome to come up as well. Otherwise, we'll just finish with Logan in the TLS presentation once we get the audio straightened out.
And now, how is it? Better?
It's probably a little better. We're still working on it. Yeah. Okay. Well, why don't you go ahead and go, and if it gets bad, we'll stop you. But otherwise, you can go, and I'll advance slides for you.
Thank you. So, our aim here was to look at TLS 1.3 during the IETF 101 hackathon. So here, what we are doing is, can you go one slide forward, please? Charles? Yep. Okay, thank you. So the goal here is mostly around application integration. OpenSSL has put out a release of OpenSSL with TLS 1.3, and the goal here is to work with the draft 23 and work with upstream open source project, so that you can, for example, take something like wget and just specify, I want to do a TLS 1.3 only connection. So the idea is to implement this across a range of open source projects. So now that we are getting very close in the working group to finalizing TLS 1.3, the idea is more integration into application packages, and let's see what breaks there. Okay, so this is what we got done. wget, it was done just a few days before the IETF 101 hackathon. Monit was done since IETF 100 hackathon. This time we just did a test with the latest OpenSSL release, Nagios plugin, check HTTP. The pull request there was reviewed positively, and it's going to be in the next release. HTTP perf pull requests already merged. Nice thing is that now with Git, you can specify that you want TLS 1.3. And something that I didn't mention also is Mercurial. STNL, the batch has been sent to the mailing list. And then there's another Nagios plugin, CheckCert, which has been merged on the first day of the hackathon. And then there's another tool known as OYA2C, which is a HTTPS downloader. And then the interesting one is Eclipse PAO. It's basically a MQTT library, and it lacked TLS 1.3 support, so it would go only up to TLS 1.2. So it's used for machine-to-machine communication. And then there's Hitch, which is basically a TLS proxy. The patch is still work in progress. So what we learned, basically we had to work with upstream projects, because if you don't follow up with your patch becomes stale, and that's an issue. Also, when it comes to integration with application, we also have to take into account compatibility with all the OpenSSL releases, which makes the integration harder. And interoperability testing with multiple TLS 1.3 server implementation revealed a number of bugs, actually. So, for example, in one particular case, we were able to debug a TLS 1.3 client hello packet, which was actually not well constructed. So with tools like Wireshark, this makes it really, really helpful to debug TLS 1.3. And one of the things that we learned is that we should have sent the announcement earlier so that we could have got more people. So the team is completely remote from Mauritius. So we met in a place called Bagatelle in Mauritius. So there's quite a few people who were involved. So I've just included a few pictures of the remote participants.
I think you guys had better weather and more fun than we did.
So again, thank you to everybody. Nick Sullivan, particularly. Thanks to Charles, who was very helpful, and to be the chair of the IETF Hackathon session. The Miteco team, which has been very, very helpful. Also to the open source developers who took time to review our patches during the TLS 1.3 hackathon during IETF 101. And again, on behalf of everybody, I would like to see more people participate in TLS 1.3, maybe at the next IETF.
Okay.
Thank you very much.
Great. Okay, thank you, Logan. And to the whole team there. All right. No one else, right? Or we're done with presentations? Anyone else? Last chance. You can run up here. And remember, even if you weren't doing a presentation here, if you have some results, are you waiting to do a presentation? No, okay. Still upload your, if you have some slides that are useful and you don't feel like presenting them here, that's fine. Upload them to that same GitHub repository, and then I'll transfer those all to the meeting materials so that we have a record going forward that's associated with the with this meeting. So a couple of things now. One, Tuska, are you here? First of all, I didn't want to say anything before the presentation started because I was counting on the network to be up. And it was, and so I really want to thank everyone who, especially Con and Chris Tuska, who kept the network up for us. If either of you are here, first of all, big applause for them. So, you know, they really did a great job of meeting as many of our requirements for the hackathon, special network setups and whatnot as they could. The one thing they did ask me was, next time if we could get those in even earlier. They ship all their gear about a month before. So for IETF 102, they're going to ship all the gear out a month before. If they have requests for special things, they do the best they can with what they have here. But if they learn about those requests ahead of time, then they can do even more for us. For example, some people asked for VMs if we had the ability to spin those up. If you let us know ahead of time, then yeah, we'll send a server and be able to spin those up for you and get them on the network. Just as an example. So anything you think you're going to need, I know it's hard to plan ahead, but think about that and please do plan ahead. Other than that, I do have a couple slides that I want to share. So let me get my laptop. And I want to thank everyone for being so good about the presentations and listening too. And as always, we'll be looking for ideas about what we can do to improve things in the future. So hopefully, I think putting things in GitHub seemed to work pretty well. And it has some other side benefits too. You don't need to read my email, sorry about that. Okay, so what I wanted to show was just a couple reminders for what we still have to come. So after we leave this room, it's going to get converted into the IETF lounge. And part of the IETF lounge is going to be the code lounge. I'm not sure exactly where it'll be, but it'll be in this room. It'll be pretty easy to find. It's just going to be a portion of this room that's kind of set up for coding, or maybe it'll be the whole room. But anyways, if you come to this area, you're sure to find it. And you can schedule a time if you click on this link. And there's a link in the wiki for the hackathon. You can set a time when it's mainly just for scheduling to help your team know, hey, we're going to be here at a specific time, and to let other people who are interested in coming and working with you know that you're going to be here at a specific time. So you don't have to schedule time. It's not like we turn anyone away. It's just to help you with your own time management. The other thing is what we haven't done before. This is an attempt to find a nice thing to replace what we're missing now by not having bits and bytes anymore. So we're calling it Hack Demo Happy Hour. It's going to be in here as well. The thought is you can set up your whatever your demo is, or just set up some space here during the day tomorrow, and then from 6 to 8, we're just going to have some light refreshments here, and there'll be non-alcoholic drinks. There will be a cash bar if you like having a beer or a glass of wine. But really the idea is to have a couple hours where people can come and talk to you in depth about your project. If you have a demo, you can show them the demo. You can run them through your slides. They might want to see your code and learn what you did, how to get access to it, how to build your project. They just might want to ask you questions, whatever. So it's kind of a social atmosphere where you can have those more in-depth conversations that we couldn't do here with a 3-minute presentation. So for that, we would really appreciate that you sign up. Again, it's not so much that we have a shortage of space, but that's the only way that people will know what projects are going to be here. So the sooner you sign up, the sooner anyone else interested in that's thinking, hey, should I go to that thing or not? They'll see, oh, hey, the QUIC project's going to be there. Cool, I really want to see that, or whatever your project is. So I recommend you register as soon as possible if you're planning on doing it. And if you haven't already, please go ahead and do that. The links for that are also in the hackathon wiki. All right. So as we always do, I would love any feedback. Good feedback's always nice to hear, but any constructive feedback, any criticism, that's good to hear too. So if you feel like sharing something or have an idea and you want to share it publicly now, that's fine. You can shout it out or run up here. Grab me any time during the week. That would be fine as well. Yeah, we ran out of shirts. So I did a great job. We actually got the shirts here on time, but we only had 200 of them. And we had, as of lunch yesterday, we had 225 people in the room. That's not counting the remote participants. So sorry that I don't have more shirts. We're not going to get more shirts. I want to thank, I do have a slide thanking my team because they put up some money so that I could get shirts, but only enough money to get 200, which seemed like more than enough. But the response here and the turnout was fantastic. And I really want to apologize for the lack of shirts, but thank all of you because as you know, that this hackathon doesn't happen unless we have champions coming here leading projects, participants participating in those projects, and it's really amazing the way all of you turn out, sacrifice your weekend. And fortunately, we didn't have to compete with the weather so much because I don't think anyone wanted to be out in the snow. Maybe that helped, but no, really, seriously, I appreciate everyone taking advantage of this opportunity And we're seeing great work. Take what you learned back into your working group. I think that's fantastic when that happens. And do spread the word. Seeing so many first-time IETF people here is fantastic. And for those of you who came and you're not staying for the meeting, I hope you do stay involved with the IETF in other ways, through the mailing list, you know, whatever, and maybe consider a future IETF meeting. We'll definitely be having the hackathon in Montreal. Almost positive the dates will be exactly the same, the Saturday and the Sunday, same format. Hopefully we'll get a really big room. Hopefully we'll get enough t-shirts. And I think that's all I have to say. Barry.
I just wanted to thank Charles because he doesn't get thanked enough for the great work he puts in with this. It's a lot of work.
Okay. Wow, we actually finished a little early, so so thanks again. I hope everyone has a great week here, or you know, evening if that's all you're staying for. And yeah, thanks for what I think was the biggest and most successful hackathon yet.